Then we discuss one of the most important content in this lecture is Kirchhoff's current laws, KCL. Kirchhoff's current laws can be represented in two ways. One way is that for any node, the algebra sum of the currents flowing out of the node is always zero. It can also be expressed as sum of the currents flowing into the node. Both are constant. Well, for this node, if we write the equation using the algebra sum of the current outflow, how will we get the equation? For I1 is flowing in, so the outflow current is minus I1. I2 is outflow, that means plus I2. I3 flows in, that means minus I3. I4 is outflow, that is plus I4. The sum equals 0. That is Kirchhoff's current law for this node. We can rewrite this equation as I1 plus I3 is equal to I2 plus I4. Look at this equation. What kinds of conclusion can you get? Very good. That is, for a node, the sum of the currents flowing into the node is equal to the sum of the currents flowing out of the node. These two approaches are both correct. Okay, we do an exercise now. For this problem, some currents are given. We need to find I1 and I2. Well, for this node, it should be 7 plus I1 equals 4, obviously. So I1 equals minus 3. Next, for this node, the sum of the currents flowing into the node equals the sum of the currents flowing out. It is 10 minus 12 equals I1 plus I2. Substituting I1 for minus 3 into it, we can get I2 equals 1. Next, we extend KCL from a specific node. That is to say, for a network, if it is connected to other circuits only with 3 branches, the currents of these 3 branches are represented as I1, I2, and I3 respectively, then we can consider the network as a node. It can be written that I1 plus I2 plus I3 is equal to 0. It is called the generalized KCL. Applying the generalized KCL into a port, the port has only 2 branches connecting with outer part. It is clear that the current flowing into this terminal is equal to the current flowing out of the terminal. In other case, a network has only 1 terminal connecting with outer circuit. We can know current is equal to 0 according to the generalized KCL. You may ask that why is the function of a network with only a branch connecting with the outer part? We will give the answer to this question in the following lectures.